In this section, let's have a first demo of Kubernetes objects. We will see how some of the fundamental Kubernetes objects like pods, deployment, and services are created and managed using Kubernetes CLI. Let's go to my terminal where I can SSH to my cluster. So I create a new session. Let me make it a bit bigger, zoom in so that you can clearly see what I am doing. The cluster that we are working with, the Kubernetes cluster, has been created by Nokia Container Services, NCS tool of Nokia. And in order to connect to the cluster, we need to have the IP address of the controller node and also the PEM key that will be used to SSH to the node. Let me run this command. The SSH, we already did our SSH and we are logged into the controller node. Because I need to add and remove objects to this cluster, let me switch to the root user and we start working with our Kubernetes cluster now. The tool that we will be using, the CLI tool of Kubernetes, as you may already know, is kubectl. And basically, kubectl has two very basic commands, get command and describe command. Let's describe. So both of these commands get the name of object after you enter the object or component after you enter get or describe. So for example, here, let me get the list of the nodes on the cluster. As you see here, there are 1, 2, 2 to 9. There are 8 nodes on my cluster. 3 of these nodes are controller nodes that have been created for high availability, and 3 other nodes are worker nodes, and NCS also needs to have another type of node called edge node, which is basically a worker node but is used to control the incoming traffic to our cluster. We will look at the ingress object of Kubernetes later in a later module, but for now, just remember we have 3 worker nodes for higher availability. We have SSH to the first one, and there are 3 other worker nodes, 5, 6, 7, and 8, 9 are edge nodes. If let me quickly show you the same information on the NCS GUI. I can log into the NCS portal here, and it provides me a lot of information here about my cluster. Here, for example, under NCS, under cluster, you see the list of my nodes, nodes 2, 3, 4 that we saw there are my controller nodes. One thing to remember here is that TC006 is the name of my cluster, and the node at the node part is the node number. So I have 3 controller nodes, nodes 2, 3, 4. I have 3 worker nodes, nodes 5, 6, 7, and I have 2 edge nodes 8, 9, which have some extra components like ingress for controlling traffic into our cluster. And storage nodes, as you see, are basically the same controller nodes. So we use storage nodes. We use control nodes both for as the controller node of our Kubernetes cluster and as storage nodes. Here on the GUI, I can get a lot of more information. For example, under portal, I see the Kubernetes dashboard. If I connect on this one, it connects me to the Kubernetes dashboard, which provides more information in terms of what kinds of objects, which are also called workloads here, are deployed on my cluster. Here, for example, I see the list of my pods, all the information about the pods, which node it's been deployed on, and I can see list of my services, I can see my deployments, and so on and so forth. So here you can get a lot of information about the cluster what objects have been created, what are the resources, and so on and so forth. Let's go back to our terminal. Okay, let's try the next command, kubectl. Again, we go with get, and now I want to see the list of pods that have been created on my Kubernetes cluster. You see, here it says no resource found in the default namespace. Basically, it tells me that default namespace doesn't have any pods deployed. Let me get a list of my namespaces. So again, kubectl get and the name of the object or component namespaces. You see here there are multiple namespaces already created on my cluster. The default is the one that we saw, but there are namespaces for the Kubernetes components called kube system. We have our user namespaces for administrator and for our projects, and the NCS where NCS deploys its own object. So as we saw in the lectures, in the previous slides and in these modules videos, namespaces are logical partitions of Kubernetes cluster. Using namespaces, we can provide isolation for every object that we deploy in Kubernetes. So here you see the reason we have so many namespaces is that we want to provide isolation between different projects. Using this isolation, I can have different kinds of objects, pods, services, deployments, stateful sets, daemon sets, all kinds of objects that are limited into my own namespace. So if I create a pod in this namespace, the other namespace is isolated from the same a pod with the same name in another namespace. That's basically the idea in Kubernetes. Let's go to a namespace which has pods. So let me first get the list of all pods in my cluster. If we use the -a option, it shows all the pods in every namespace, every one of these namespaces here. So if I run this command, you see there are different kinds of pods in different namespaces. In kube system, you see these control manager namespaces. You saw in the slides that these are the controller manager part of the Kubernetes, and because we have 3 controller nodes in our cluster, we have 3 controller manager, kube proxy on the worker nodes, which receive the commands from the kube API server. You see there is a kube proxy in every node of the cluster. There are eight of them because we can deploy pods on both controller nodes, worker nodes, and our edge nodes. And we have in another namespace on the left side, you see the namespace name, by the way. In the NCMS namespace, you see all the pods that have been created for the NCS, and there are a couple of namespaces for our projects, which we have already deployed a couple of MRF application, and you see here there are pods. There are 2 pods with this name, and OAM pods for MRF. There are 2 containers in this pod and 4 containers in this pod. And you see all of them are in running state. If you want to see the list of pods in a specific namespace, we say -name, for example, cube, and the name of namespace system. And now I can see then the pods only in this specific namespace. We see again the same kube proxy pods and controller manager pods and core DNS pods, which are basically our DNS pods in the Kubernetes cluster. Now let's go and do our first deployment. We start with the most basic object in the Kubernetes cluster, which is pod. Let me go to this folder on my controller node, Kubernetes manifest. And as you see here, I have a list of, I have already created a number of YAML files for different kinds of objects. Let's look at the nginx pod. You see here the YAML file for a pod, as you saw, has as any other kinds of objects, YAML file has 4 mandatory fields. API version, most of the times it's v1, but it could be different in different objects. We have the object type or kind, which is pod here. We have the metadata where we store information about our object that is being created. For example, a name or label or other kinds of information go here. And under spec, which is basically the most important part, we specify what are the specifics of that object. Here because we are deploying a pod, we need to specify what is the container or containers that we run inside the pod. The name of this container would be nginx. There is a single container called nginx, and this is the place, the image that we want to download. So on our cluster, we have access to this Harbor registry. We don't have access to the open internet, but we have access to this registry. So we are saying go to this Harbor registry and download the latest version of nginx. As you know, if we don't specify .label, it downloads the nginx image with the latest label. Let me go quickly back to my browser and show you my Harbor. So this is the Harbor registry where we have access from our Kubernetes cluster, from our NCS cluster, and I have already uploaded a number of images into this Harbor. We have BusyBox. We will see it during our demo. Ubuntu for running Ubuntu Linux container or pod, nginx, and our application, MRF application images. So if I go into, for example, nginx, you see I have uploaded 4 nginx Docker images to this registry with tag 1.16.1, 1.14.2, 1.28, and the latest. And this is the latest one, is the one that we want to use to deploy our pod. Going back to our pod, let me go and create this pod. The command, again, as always, starts with kubectl, and for creating objects or for updating objects, if we go back and update this YAML file, we use apply in Kubernetes, kubectl apply. From which YAML file? From my pod nginx, right? And it takes a moment and the pod is created. So let me now get the list of pods in my default namespace. As you see here, the pod has been created and it has one container. The container is running and the whole pod is in running state. If I use -o white with the same command, it provides me more information, including it's telling me which worker node the pod is running on. And as you see, the scheduler has gone and scheduled the pod to be running on this node. And there is an IP address already assigned to the pod for communication to the outside world, and it's in the running state. Now, another very important command in Kubernetes, which we use for a lot of checking and debugging purposes, it's describe. And then after I say kubectl describe, I have to say the type of my object, which is pod here, and I want to see this pod's details. You see here, you see here a lot of more information about the pod. What is the node it's been deployed on? We saw that in the output of this command, the previous command as well. The same node, node 7. We see the IP address of the pod, which we saw above. We see the image that has been downloaded for this for the container running in this pod. And at the bottom, this part is very important, the part called events. And you see here under events, we see all the events that have happened for this pod to be deployed. it goes from up to the bottom. The first event was happened about 75 seconds ago. The pod was scheduled by the default scheduler on the controller node. Then our CNI assigned an IP address to this pod. Then the kubelet on this node 7 pulled the image from repository and created the Nginx pod for us. Okay, so far so good. Let's proceed with deployment of more objects. The next object for us to deploy is a deployment object. Let me explain to you why we cannot depend on pods only for deploying our applications. If we already deployed our Nginx pod as you saw a moment ago. So I have an Nginx pod providing Nginx service to me. Assume I am another pod, I am another application running in the same cluster and want to access the service of this pod. What happens if this pod dies for any reason? If the pod dies, there is no Nginx service in my cluster. So in order to provide resiliency, we normally deploy our applications with multiple pods. And that's what deployment provides us. With deployments, we can say how many replicas of that pod we want to create. And this is the object that we will be creating now. So let me look at another YAML file in this cluster. As you see here, again, I have my app API version. This mandatory field is apps v1. The kind of object I'm deploying is deployment metadata as before. And under spec, I am saying how many pods I want my deployment to have. I want to have 3 pods, and how these pods are connected to this deployment. It's by this selector. So the deployment object will create 3 pods with this label. The label of each pod would be app nginx. And what are the pods? The specifications are explained here. Under containers, the same nginx image that we use to deploy our pod, we use the same image, and we create 3 pods from this container, and we label them as app nginx. Okay, what you see down here, we see through our demo probably is being automatically created by the NCS, and we can ignore it. So let me go and deploy my deployment kubectl. Again, apply what file deployment nginx YAML. And when I run this command, it says the object was created, kubectl get deployments is the command to check what deployments I have on my cluster. And as you see, I have one deployment, Nginx deployment, and it was just created 13 seconds ago. So my deployment was created. And if I say kubectl get pods, and let's go -oy to see more information. You see that my deployment created 3 new pods with this name Nginx and Nginx deployment, which is basically the name of the deployment. And for the pods, Kubernetes adds a hash string to the deployment name. This is the pod that we created before for using our pod deployment YAML file, and it was created 6 minutes ago. But these 3 pods were created by my deployment. And on the right side, we see the nodes on which the pods have been created. The nodes 5, 6, and 7, and the first one was created on node 7. Let me get the labels created by Kubernetes for these nodes. If we add --show labels, let me fix this typo. You see the 3 pods that have been created for my deployment have this app equal nginx label and some other labels added automatically by Kubernetes. But this app nginx is what I specified here under app nginx. So I asked a deployment with this label for the pods, and that's what Kubernetes did for me. Now we can let us see how we can edit our objects in Kubernetes. There is a simple command, the kubectl edit. I can run to edit any running object. So let me update my deployment object, kubectl edit deployment, and the name of my deployment. If I run this command, it shows me all the attributes that Kubernetes has assigned to this deployment object. Some of those attributes were specified in my YAML file. For example, the name, the image name for the containers. These are the ones that I specified. But there are many attributes that I didn't specifically specify for my deployment, and Kubernetes assigned them by default. For example, rolling update is how you can update your deployment if you change your image, if you scale up or down the number of replicas. Here under replicas, you see there are 3 replicas, and this is what we specified when we created our deployment. Let me go and change this to say 2. And I can change it on the fly here and save it and going out of here. And if I run my command, see now Kubernetes automatically picked up the change I made in my deployment object, and there is now one less pod in my deployment. So one way of changing your Kubernetes objects on the fly is using kubectl edit, the type of the object and then the name of the object that you want to change. Another way of changing my Kubernetes object is to go back and change my YAML file. Let's go here and change, say I want to change another thing. I can change labels, but let me go and change the nginx. And I would like to change the label to one of the images I had on hardware. Let's go with 114.2, or how about 116.1? Okay, let me go 116.1. So I can go here and I say, grab this image, 116.1. Don't grab the latest one. And if I store this change, save this change, and go back, and you see here still, when we change the YAML file, Kubernetes doesn't know that we changed it. So the same image is being run. Let me now go and apply my change. In order to apply my change, I need to use the apply command again and the same YAML file. And now if I say kubectl describe deployment, and which deployment? What was the name of my deployment? nginx deployment. You see here under image, it changed the image that we were using before. So it was using nginx latest before, and now it switched to nginx 116.1. And that's how you can basically manipulate or update your objects deployed on a Kubernetes cluster. Next, let's do more deployments. So far, what we did is that we created a pod initially, but we realized, okay, for resiliency, we need to have multiple pods, and we created a deployment. But again, if I am this other pod in my cluster, the customer pod, and I want to access the services of these pods, I need to have the IP address of these pods. But you saw that every pod is assigned an IP address, so I can access this nginx service on my pod. But what if the pod dies? If the pod dies, Kubernetes assigns a new IP address to my pod. This means as a customer, as a client of this pod, I need to update the IP address of my the IP address for this pod and now send the request to a different IP address. I mean, if both of them die, we will have two new IP addresses for our pod. So this doesn't seem very sustainable because as a client, I need to follow what is the IP address of the pods, and that's when the concept of services comes into place. And services in Kubernetes basically are built on top of deployment. And what they provide is that they provide us an IP address for our application. For example, if I am running my Nginx application in these pods, I can deploy my application as a service on top of this deployment object, and then the clients will access the Nginx application through this service IP address, which is going to be fixed and will not change. So the pods can come give service for some time and die, and their IP addresses changes. But the client here sends its request to the IP address of the service, and the service object is smart enough to know what are the pods which are being managed by this service, and forwards the traffic in a load balance way to the backend pods. So let's go and add a service to our already existing deployment. Let me look at this service that I have here, service YAML file that I have here. You see again the API version is v1, kind of the object will be service, the name of the service is Nginx service, and under selector I am saying what is my deployer, what are basically the pods of the deployment object that I want to run this service on top of. And this is the label that will be chosen to deploy the service on top of the deployment. So Kubernetes, when it wants to deploy this service, looks at the pods deployment, which has pods with this label, and adds the service on top of those that deployment. And under ports, we have the target ports, which is the port that the container uses, but we have another port number 3000. This is the port on the node which my traffic will be sent to, and the Nginx service forwards that traffic to the backend pods with this target port number. Okay, let's go and deploy our service again. kubectl apply as always -f service nginx.yaml. The service was created. kubectl gets services. A typo here. And you see that in my default namespace, I have this Nginx service created on this IP address. The first one is a Kubernetes service which has been created by default by the Kubernetes in the cluster for accessing Kubernetes service itself. But this is the one that we want to focus on. And you see here the same port number that we specified, 3000 here. Through TCP traffic is being shown here, and the IP address of service is 10.254.32.72. The type of the service is by default cluster IP because I want to access this service only from inside my Kubernetes cluster. So if I wanted to access the service from outside the Kubernetes cluster, I would have gone with the service node port or load balancer. But in this first one, we have a cluster IP service. Now let's get let's get more information about our Nginx service. As before, we use the describe command, and we look at more information here. The namespace is default because we didn't specify any namespace in our YAML file. no labels for the service. Basically, the type is cluster IP. Selector is app equal nginx, and this is the same IP address I saw above. You see here, you see it here, and the ports 3000 TCP, target port 80 here. You see here, I specified here, and one thing we are seeing is that there is no endpoints. Means that if I now send a request to this service, there is no backend pod. So basically, I would not get any response. Let me see. I think I have a curl on my controller node. I want to send a request to this this service. That's how you send the curl command. Basically, I need to have the IP address of my service and then the port number on which it receives it's supposed to receive the curl command or traffic request, which is 3000. And I suspect this fails because there is no backend path. So okay, it couldn't reach. There was no backend path. Let's see what's the reason. Let's do some debugging here. So we are creating the service successfully, but what is missing is the endpoint. So somehow the service cannot find the paths of the deployment on top of which creates the service. If you look at the selector here, you see that it says go and find the backend pods which have this label. And if I run my pods dash show labels again, you see I have already 3 running running nginx pods with this label app equal nginx. And my goal was that I add my service on top of this deployment already there. But you see the label has a small typo here, app equal nginx here compared to app equal nginx here. So because I asked Kubernetes to add my service on top of pods with app equal capital N nginx, it couldn't find any backend pods for its endpoints, and that's why you see here there is no endpoint. So let's go and change this label in our service and see what happens. kubectl edit service nginx service, and here we can go and change our fields on the fly. What do I want to change? I want to change the selector, which is basically app capital N nginx. I want to change this to N and save it. Make sure we make no mistake here. Escape WQ and again Kubernetes quickly picks up this change, and if you run this command kubectl describe service, you see 3 endpoints added to this service, and these endpoints are my 3 nodes from the deployment. kubectl, if I run this command get pods -oy to see my IP addresses, you see these 3 IP addresses here, 24, one of my nginx deployment pods, 50, this one, and 27, the third one. So if I use the right label, everything is all right, and I have my backend pods. Now, if I run the care command again, you see now the care request goes to the service. The service receives the request on port 3000. It forwards the request to one of the backend pods, one of these 3 pods on port 80, and these containers running in these pods are listening on this port 80 and respond to my request that I am an Nginx server and the other information provided. So basically that's how we can create basic objects in Kubernetes. We can edit them, we can change them if required, and see if they are working properly. Now, how do we clean up the objects that we created? There is a kubectl delete command similar to kubectl get, describe, apply. And what I want to delete, for example, I want to delete my Nginx pod. Delete F, I can delete -F, I can say go and delete my pod Nginx, right? And if I run this command, it gracefully deletes my Nginx pod. It took a while. And if I say get pods, you see there is one less pod. Now, if I go and delete I can also delete my pod using CLI delete pod and say let's delete the first one. If I delete my pod using delete pod command, not using the delete -F, the name of the YAML file, this one, what happens is that it deletes my pod. And see, if I run the same command, if you pay attention here, the two pods, the 5M is already here. The BP is already here, and basically what happens is that Kubernetes, the controller for this deployment knows that there should be always 3 replicas of this pod. So because I deleted that pod, which was created 13 minutes ago, it quickly went up and created a new pod for me, which was created 4 seconds ago. So if I add if I delete my pods here, because the deployment object from which I created these pods has a controller, the controller knows I need to already maintain three replicas of this pod, and it goes and creates the pod for me again. So the right way to delete the deployment object is to go and delete it through the deployment. We can of course delete our deployment object, but let's go and delete the service object that we created first. Deploy service nginx.yaml, yeah. And if I delete my service and send the same clear command, it fails because that service is gone and there is no IP. This IP address is not serving that service anymore. And finally, so if I say kubectl get services, I see the service is gone as well. And finally, let's delete our deployment just to clean up everything we created. Get deployments. And you see there is no deployment. So another command that I can use in this namespace, default namespace, is kubectl get all, and basically it shows a list of all objects in this default namespace. So I have only this service running in this namespace, and if I want to run it in, say, another namespace, I run in using this command. So in this namespace, we have many different kinds of objects created. We have pods, we have services, we have daemon sets, we have deployments, and we have replica sets. So that's it for this demo. For the first part, I wanted to show you how we create these basic objects. And in the next second part of this modules demo, We will take a look at other kinds of objects and also some of the basic components of Kubernetes.